I will teach you how to solve simultaneous linear equation using Jacobis iteration method. So let us consider the system of equations a1x plus b1y plus c1z equals to d1, a2x plus b2y plus c2z equals to d2, and a3x plus b3y plus c3z equals to d3. So here a1, b1, c1, a2, b2, c2, a3, b3, c3 are the coefficients of unknowns x, y, z. We have to find the unknowns x, y, z, and d1, d2, d3 are the constants. So first write the equations in terms of x, y and z. If a1 is greater than b1 and c1, then write the first equation for x1 x. So just rearrange this equation. a1x equals to d1 minus b1y minus c1z, or x equals to 1 by a1 d1 minus b1y minus c1z. And if b2 is higher than a2 and c2, then write this equation in for y. So b2y equals to d2 minus a2x minus c2z, or y equals to 1 by b2 d2 minus a2x minus c2z. And if c3 is larger than a3 and b3, then write the equation for z. So c3z equals to d3 minus, just I am rearranging the equation, d3 minus a3x minus b3y. So that equals z equals to 1 by c3 d3 minus a3x minus b3y. So in the first step, just rearrange the equations. If a1, b2 and c3 are higher than or larger than the other coefficients, then solving these equations for x, y and z. So this is the first step. So just rearrange the equation for x, y and z. Two and 3. Now in the second step, just put x initial values x and x, y naught and z naught equals to 0. Just in this equations 1, 2, 3, substitute y value and z value equals to 0 and find the x1 value. Similarly, substitute x and z values 0 and find the y value. In the third equation, put x equals to 0 and y equals to 0, find the z value. So that gives the next approximation value. So this is the initial approximation, x naught, y naught, z naught equals to 0. So then we will get the, after substituting the x naught, y naught, z naught equals to 0 in the first 1, 2, 3 equations, you will get the x1 value. So what is the x1 value? If y is 0 and z is 0, x1 equals to d1 by a1. Similarly, y1 equals to x is 0 and z equals to 0, so d2 by b2, and z1 equals to d3 by c3. So this is the first approximation, x naught, y naught, z naught equals to 0, and we will get x naught, y naught and z naught equals, z1 equals to some values. For the next approximation, use these values. And the same procedure is repeated till the last two approximation values are same. So this is the procedure to find the solution of a simultaneous linear equations using Jacobis method. Solve 20x plus y minus 2z equals to 17, 3x plus 20y equals to minus z equals to minus 18, 2x minus 3y plus 20z equals to 25 using Jacobis iteration method. So the first step is observe the coefficients of x, y, z. So here the x coefficient is 20, y coefficient is 1 and z coefficient is minus 2. So 20 is higher than y and z coefficients. So write this equation in terms of x. So 20x equals to 17 minus y plus 2z, or x equals to 1 by 20 into 17 minus y plus 2z. So this is for x. So similarly, observe the coefficients of x, y, z in the second equation. So x coefficient is 3, y coefficient is 20 and z coefficient is minus 1. So y coefficient is higher. So write this, rearrange this equation for y. Just y equals to 1 by 20 into minus 18 minus 3x plus z. So similarly for z, z equals to 1 by 20, 25 minus 2x plus 3y. So these are the equations in terms of x, y and z. Now x naught, y naught and z naught equals to 0. So our approximation starts here. So first approximation value, for first approximation, just x naught, y naught, z naught equals to 0. So substitute and write the x value. So x1 equals to 1 by 20, 17 minus y naught plus 2 z naught. So that equals to y naught is 0 and z naught is 0. So 17 by 20. So 0.85. And y1. So y1 equals to 1 by 20, 17 minus, y1 equals to 1 by 20 minus 18 minus 3x plus z. So these are x naught and z naught. So x naught, z naught values are 0. So minus 18 by 20. So that equals to minus 0.9. Now z1. z1 equals to 1 by 20, 25 minus 2x naught plus 3y naught. So 1 by 20 and the x naught and y naught values are 0. So 25 by 20. So 25 by 20 is 1.25. So x1, y1, z1. So we can use these x1, y1, z1 values for the next approximation value. So for the next second approximation, second approximation or second iteration. So x1 is 0.85 and y1 is minus 0.9 and z1 is 1.25. So x2 equals to 1 by 20, 17 minus y1 plus 2 z1, and y2 equals to 1 by 20 minus 18 minus 3x1 plus z1, and z2 equals to 1 by 20 25 minus 2x1 plus 3y1. So substitute y1 is minus 0.9 and z1 is the 1.25. So similarly x1 is 0.85 and z1 is 1.25, and z2 x1 is 0.85 and y1 is 1.25. So after substituting these values, you will get x2 equals to 1.02 and y2 equals to minus 0.965 and z2 equals to 1.1515. Now compare the x1 value and x2 values. So these two are not same. So you go for the next approximation value. So for the next approximation, x2, y2, z2. x2 is 1.02 and y2 is minus 0.965 and z2 is 1.1515. So this is third approximation, third iteration. So first x3 is 1 by 20, 17 minus y2 plus 2 z2, and y3 is 1 by 20 minus 18 minus 3x2 plus z2, and z3 is 1 by 20 25 minus 2x2 plus 3y2. So now substitute y2 and z2 value. y2 is 1.02, y2 is minus 0.965 and z2 is 1.1515 in this equation. So after substituting, you will get x3 is 1.0134 and y3, and substitute x2 is 1.02 and z2 is 1.1515. Then you will get minus 0.9954. And for z3, substitute x2 equals to 1.02 and y2 equals to minus 0.965. Then you will get 1.0032. So these are the new values x3, y3 and z3, and compare x3 and x2. So here x2 is 1.02 and this is 1.0134. So those are not equal. So then you go for the next iteration. So the fourth iteration. Fourth iteration, x4 equals to 1 by 20, 17 minus y3 plus 2 z3, and y4 is 1 by 20 minus 18 minus 3x3 plus z3, and z4 equals to 1 by 20, 25 minus 2 x3 plus 3 y3. Now substitute. Y3 is minus 0.9954 and Z3 is 1.0032. Then you will get 1.0009. And substitute x3 value is 1.0134 and Z3 is 1.0032. Then you will get minus 1.0018. And for Z4, substitute x3 equals to 1.0134 and y3 equals to minus 0.9954. Then you will get 0.993. So these are the new values. So x4, y4 and z4, and compare x4 and x3 values. So those values are not same. So you can go for the next step, approximation. So that is the fifth iteration. So fifth iteration. So just for the fifth iteration, this is x5 and y4, z4, and for y5, x4, z4, z5, x4, y4. So y4 value is minus 1.0018 and z4 value is 0.993. So after substituting, you will get x5 value is 1.00, and similarly x4 is 1.0009 and z4 is 0.993. So substitute those values, you will get minus 1.0002. And z5, substitute x4 equals to 1.0009 and y4 equals to minus 1.0018. So z5 equals to 0.9996. And now compare x4 and x5 values. So these are closely same. So then we can go for the next approximation, sixth iteration. Sixth iteration. For sixth iteration, x6 equals to 1 by 20. Just I am writing those equation. 17 minus y5 plus 2 z5, and y5 is minus 1.0002 and z5 is 0.9996. Then the value is 1.00. Similarly, y6 is 1 by 20 minus 18 minus 3 x5 plus z5. So here x5 is 1 and z5 is 0.9996. Then y6 equals to minus 1.000 and z6 is 1 by 20 25 minus 2 x5 plus 3 y5, and x5 is 1 and y5 is minus 1.002. Then z6 value is 1. And now compare these two values. x6 is 1 and x5 is 1, and y6 is 1 minus 1 and y5 is also minus 1.002, and z6 is 1 and z5 is 0.9996. So we can stop the iteration procedure, and the solution for the given problem is x equals to 1, y equals to minus 1 and z equals to 1.
If you feel this video is informative, please like, share and subscribe my channel. Click the bell icon for quick updates.